All right, we have 1 minute to go. Are there any questions? Anything? Okay, so today we'll continue last week, week 9, and then finish week 10. Sorry, I catch a cold. Maybe I need to to cough. Thank you. Sorry for the inconvenience. Okay, first of all, can somebody confirm that you can hear me and you can see my screen?
I can see and hear you.
Oh, thank you so much. Great. So last class we finished up to here, example 4. Now we continue here, the definite integral as a measure of net change. So in real application, we often interested in the net change of a quantity over a period of time. For example, P is a function given to population at time t. So we want to know the net change in population over the period from time A to time B. So we are using PB minus PA. So P is the function of the population. Now using integral, PB minus PA. Thank you. PB minus PA can be written as a definite integral from time A to time B. Okay, and then P prime T dt. So remember what is the relationship between P and P prime. P is the antiderivative of P prime. For example, if P prime equal to x squared, remember last, okay, maybe we take an example later. Okay, any questions so far? Okay, let's take an example. This is example 6. Clark County in Nevada, dominated by Las Vegas, one of the fastest growing metropolitan areas from 1970 to 2000. But population was growing at a rate. So this is the rate of population. T equal to 0 corresponding to 1970. The question asks you, what was the net change in the population over the decade from 1990 to 1990? So I pause for a moment, let you to digest this example. Okay, remember this RT function is the rate. And we are asked the net change of the population. So we can just plug in this formula here, use this formula, okay? So it is actually by the way, t equal to 0 represent 1970. So this is 1980, t equal to 1, 1990, t equal to 2. So the net change, it is actually from 1 to 2. From 1 to 2. The rate RT dt. So that is the solution. Any questions?
I have a quick question.
Yes, please.
Wouldn't 1980 and 1990 be 10 and 20?
Thank you for your question. From 1970 to no, because T represent 1T represent 1 decade. 1T does not represent 1 year.
Okay, thanks.
1T represent 10 years. Okay. 1 unit of T represent 10 years, not 1 year. Thank you for asking. Okay, I pause for a moment to see if you have any other questions. Okay, so now let's solve this question. So we just need to evaluate. So take the integral of RT. So take integral of RT, and then from 1 to 2, integral equal. So this is constant. T squared. So 1 over 3 T cubed minus, copy down the constant T, 1 over T squared. Here we are using xn. So this is the foundation, okay? And last item. And again, 1 to 2. Any questions? So once you are here, first plug in T equal to 2, then minus T equal to 1. That is the result. Let's show you here. We are here. So first plug T with 2, then plug T with 1, do subtraction. Questions? Questions? Okay, next example. Example 7. Please read the question by yourself. I have, then we solve this question together. Give me a moment. Example 7. Okay. So this is a marginal cost function, C prime x, marginal cost function. And then question asks you for total cost. The given function is marginal cost. The question asks you for total cost. Okay, so question A, what is the total cost for the first 500 units? So it should be integral from 0 to 500, right? And then C prime x. That is the formula for A. Questions, total cost. Question B, what is the total cost for 200 go first to 400? So the second one, because it is a total cost. Okay, so you should start with 200 and end with 400 and C prime x dx. Any questions? So now the question becomes, so let's solve for A. Why not? The question asks why not 201? Let me see how to explain this. Okay, that is the question. Thank you for asking the question. Because the question asks you from 201 sorry, to 400 means cost for 201, cost for 202, 203, blah, 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 until cost for 400. Okay? And what we want to do, we want find the total cost up to 400 minus. If you do this one, this represent cost from 202 to 4,000. That is what we not what we want. We want 201 to 400. Okay. And another, maybe I will explain again. Try to use a simple example. Okay, draw a diagram. So we want the cost for 201 to 400. Okay, so this cost from 201 to 400 should be Excel. So this is 0, 1, 2. You can imagine until 2,201. And then 400. Okay, so this is 400. Okay. Now we want the cost from 201 here. We want the cost from 201 to 400. Okay, so the data with yellow background, don't you think equal to all the column A minus actually from total cost from 2001 here. So minus so should be start from 2000. As you can hear. Okay. If you use 2001, it becomes the total cost from 2002 through 400. Okay. Yeah. Okay, any other questions? All right, so let's solve this question. So question A, it becomes from 0 to 500. From 0 to 500. Okay. It is from 0 to 500. And then dx. So it is equal to 0.0. So copy down the constant. And then use fundamental x and dn. Okay. Use this one, you go to 1 over 3x cubed minus copy down. So x becomes 1 over 2x squared. And plus 4 means plus 4x. And then you plug in 500 and then minus 0. So the solution becomes here. Here. Any questions? And for part B, you just do 200, 400, and then find antiderivative. Any questions? All right. So this is example 7, and this part is not required validity. So we finished last week. That is week 9. Questions? So now we go week 10. I'm very sorry, I'm not feeling well today. We may finish early, okay? So week 10 now. Show the answer for part B. Thank you. The answer for part B. This is the answer for part B. Okay. We start this session by listing some properties of definite integrals. So I pause for a moment to let you read over those 1, 2, 3, 4, 5. I give you example, for example, 2 to 2. This one equal to 0. The second, 4 to 6, x squared dx is equal to negative from 6 to 4. Okay. Number 3 is obvious. So if you have 1, 2, 3, and ex, maybe 3ex, dx, it's just move the constant in front of integral. Number 4 is obvious. Okay. Number 5, I give you example. 2 to 6, x squared dx, it is equal to 2 to maybe 3 plus 3 to 6. Method of substitution for definite integrals. This part, you need lots of practice. Lots of practice, okay? To practice, when you go home, you do this example first, then do textbook example, and then do some exercise from textbook. Okay. So, evaluate definite integral. So we usually use the u substitution. So we let u equal to 9 plus x squared. So both sides I take d. So left hand side du, right hand side d. D means derivative. Okay. Now copy down left hand side. Constant derivative is 0. Okay. So d constant equal to 0. D constant equal to 0. So d9 equal to 0. And then you have dx squared. Questions so far? So keep on going. So what is dx squared? Dx squared is just 2x dx. You should know this. Any questions so far? Now, I rearrange original expression. I forget 0 and 4 first. So don't you agree original becomes Is it the same? This is original.
Oh, yes, yes, yes.
Any questions? And now, when you use the variable u, so when x equal to 0, what is u? Anyone?
U equal to 9.
Thank you. Love your participation. And when x equal to 4, what is u?
U would be 25.
Thank you. Can you, when you, oh yeah, 25, yeah. Okay, now, do you agree? So, when x equal to 0, u equal to 9, x equal to 4, u 25, and then 9 plus x squared, that is u. Did you see that? And x times dx, x times dx equal to both sides divided by 2. Do you agree? So x times dx equal to 1 over 2 du. I pause for a moment to see if you have any questions.
I actually have a question.
Sure.
So remind me again why u equals 25?
Thank you. Why u equal to 25? Remember u equal to 9 plus x squared. When x equal to 4, u equal to 9 plus 4 squared. 9 plus 16.
Okay, thank you very much. I appreciate it.
Thank you for asking. Other questions? Okay, keep on going. So when constant can be this becomes u du, and this becomes xn dn. This is 1. Okay. So this becomes 1 plus and then 9, 12. questions. And now it becomes here. See, I am here. Keep on going, you get final result. Questions? Can you go up for a minute? Go up. How did you get 1/3? Thank you for asking. How do you get 1/3? How do I get 1/3? Keep on going. So 1 plus 1/2 is 3/2 times u. 3/2 vertical bar. Okay, and equal 2 and 2 cancelled out, so you get 1/3 u. Okay. Questions? Okay. Can I suggest we take our first break for 15 minutes? After 15 minutes, we continue. Thank you. So come back at 6:55. Right. Welcome back. Hope you have had a nice break. Are there any questions? Okay, let's continue. Please type your question in chat area or directly unmute yourself. Example 4. Could somebody please mute yourself? There is some background noise. Thank you. Found the area bounded by fx, so this is fx, and from -1 to +1, so found this area. So found the area from -1 to 1, e 1/2x dx. Okay, let's do u substitution first. So let u equal to 1/2x and then du equal to 1/2dx, both sides u. Move 2 to the left hand side, so 2 du equal to dx. And then x equal to on x equal to -1, what is u? U equal to -1/2. When x equal to +1, what is u? Okay, so this becomes from -1/2 to +1/2 because of u substitution. So u, dx. Remember what is dx? So dx equal to 2 times du. Questions? And then move constant 2 in front of integral. U du. U's minus E. And then what is E? 1/2 Excel. EXP 1/2. This number is 1.648. And then we need to know what is EXP raised to power negative 1/2. .665. Okay, and then subtract this number. Subtract this number, and the result times 2. This is the final answer, 2.08. Use EXP function. Any questions? The average value of function, we don't need this part, but we need this part, result. So we need to use this part. The average of function f over AB is integral a to b, then times 1 over b minus a. Okay, let's take a look at example. Found the average value of fx over 0.4. So based on this formula, this is average. Okay, with a equal to 0, b equal to 4 in the example. So directly plug in. Okay, and found antiderivative function. Plug in 0, plug in 4. questions?
How did the 1/4 get to 1/6? Was that like?
Thank you. Okay, let's do from here, okay?
Yeah.
So copy down 1/4. So x raised to power 1/2.
Mm-hmm.
This one we use xn, 1/n plus 1, xn plus 1. So this one equal to 1/1 plus 1/2, x1, okay? So 1/3/2, x3/2, x, okay?
Mm-hmm.
And then 1/4 times, move this is constant. I can move in front of the integral. So it becomes actually 2/3.
Oh.
Remember mathematically, if you have 1/a/b, it is equal to b/a. Okay, now 2 and 4 cancel 1. 2 times 3, 6. Yeah. Any other questions? Okay, next, find the area between two curves. If you have fx, if you have gx, how do you find area from A to B? This is the formula. Use fx minus gx integral over A and B. So generally speaking, if f greater than g, the area between f and g is here. Questions? Example. Find the area by x-axis and the parabola y equal to and then -1 to 4. So find this area. And remember, we need two functions. We need fx, we need gx. So this x is our fx, x-axis, and this parabola is our gx. The parabola is our gx. Gx is given, but what is fx for when x is x-axis? Fx actually equal to 0. All the point on x-axis equal to 0. So we got two functions, fx function, gx function, and then plug in the formula from a to b. A, -1, b is 4 in our example. -1, 4. Okay, so -1, 4. Fx minus gx, so this is gx, fx is 0, fx is 0, minus g is, so this is g. So take away bracket, directly use function, use xn okay, and this is here, final result. Any questions? Okay, in summary, so week 10 we actually finished 6.4. That is fundamental. Fundamental theorem of calculus. So what does this theorem say? So fx dx, it is antiderivative function f. The relationship between capital F and small letter f is this. So this is small f. This is capital F. This is A. This is B. So that is 6.4. Algebraically speaking, capital F take derivative equal to small f. So that is 6.4. 6.5, we did a definite interval. We did a U substitution. And we also did the average value of function. The average value of function, it is just this one. And finally, we calculated the area between two functions. So that is what we did today. Any questions? Why did you replace x with 6 and 4 in the last solution? Why did you replace x with Riley, thank you for your question. Try to locate where replace x with 64, 16, and 4. Can you specify which slide? Riley, which slide?
On slide 20.
Slide, thank you, slide 20. Slide 20.
I think what they're referring to, this is what I'm assuming. So it looks like because it's 64, 16, and 4, that's in the equation, it was x cubed, x squared, and x. So that was like a step filled in for them, that the x cubed, it was 4 cubed became 64, and then the x squared became 4 squared, which is 16, and the x just became 4. The solution above this, near the top of the slide, that's typed out. So go up a little.
Thank you, Ying, for jumping in.
Yeah, that's right. That's what I was guessing. That's what I got.
You got it? Yeah. Okay. Great.
Yeah.
Thank you again.
Ah, no worries. Yeah.
Any other questions? Okay, I just want to thank you for being so patient and so understanding. We completed today's lecture. Hopefully next week we are back to normal. That's all for today's lecture. If you have any questions, please email me, okay? I'm having difficulty speaking up today. Thank you again. Take care, everybody. Okay, good luck.
Thanks, feel better.
See you next time.
I hope you feel better. Good night.
Thank you.
Yeah. See you next week. Get better. Thank you.
Bye.
Yeah.